Hey, welcome back to Math with Patrick. Today's September 14th, and we're solving problem 257 from the Daily Epsilon calendar. And today we need to show why x is equal to 14, because 14 is today's date. And so this x right here should be a 14 by the time we're done with this problem. Looks like we're given two equations and two unknowns, r and s. Looks like r is supposed to be positive. This makes me think, is there another solution when r is negative? I guess we'll just have to see. And once we know some information about r and s from these two equations, we're going to add them together and hopefully get 14 today. So right here, I see that r and s, once we square them and find the difference between their squares, we get the number 56. And I don't know if this is going to be useful or not, but I do know that I can factor a difference of squares as r plus s, that's supposed to be an s, and r minus s. If we tried multiplying all of these out, we would need to distribute these terms and these terms with each other. And so we get like r squared from the first, we get minus r times s from these ones, we get plus SR from the inside, and then finally we get minus S squared from the last two terms. And then multiplication, you can do it either way. And so this S times R and this minus R times S cancel each other out because it'll just be the same number. And so we're left with exactly what we started out with. So I'm factoring this difference of squares just to maybe have another way to like approach it. Because when I look at this, I'm thinking, is it like 100 minus 16? Is it 100 minus 25? Is it 100 minus 36? And I think right there I kind of overshot it. Or, no, I didn't, because this one right here is going to be 64. Is it 100 minus 49? This is 51. Okay, so I overshot 56. Got it. R can't be 10. I'm assuming r and s are going to be whole numbers here, but maybe there's actually some kind of fractional answer that I'm not considering. But that's what I'm seeing when I look at the first equation. I'm thinking of like taking square numbers and subtracting them. Just for a sec, I was like, oh, can I find another one? Like, I was trying to like think, is S4 by chance? Adding 16 to this would give me 72, I think, right? And that's not a square number. So anyways, maybe there's actually like a fractional answer, not sure yet. But looking at it this way, I'm thinking like, what are two numbers that multiply to get to 56? And then they have to be kind of like bigger and smaller than this kind of mystery R number. So that's another way to approach it. We could try finding factors of 56, like 1 and 56, or 2 and, is that 28, I think? Right, because that's 40 plus 16. Yeah, okay. Let's see, 3 isn't a factor of 56, but 4 should be. And I think that's going to be, so if I doubled this, I should divide this by 2, so that's going to be a 14. And then I think the next factor pair is going to be 7 and 8. And then we're all done because the next biggest number would be 8, and I'm just going to be counting on the other side of my factor list. So I guess we could try to figure out potential values for R and S based on these factors. Like in this case, I think R would have to be 7.5, and then S would have to be 1/2 or 0.5, because then that would make this the 8 and this the 7. Here, the halfway point between 4 and 14 is going to be 9. So R would be 9 in this case, and then we would either add or subtract 5 to get to this factor pair. And actually, this one seems best because now I'm taking a look at the next equation. R times S equals 45. So this just tells me that R and S are also factors of 45, and we could run through that list of factor pairs. I do know it's 5 times 9 or 5 times 3 times 3. So this is informing me that maybe we're going to have a 1 or a 3 or a 5, and then 5 times 9 gets us to 45. And so we're doing the same thing where once we've counted this way, we're kind of counting back up. So to get factors of 45, again, only thinking in whole numbers for now. There's nothing in here that kind of says that we need to think in whole numbers, but I like to, at least to start out. We could do 1 times 45, we could do 3 times 15, we could do 5 times 9, and I'm seeing that this kind of links up with the other example. I guess technically I would need to say that R is 9 and S is 5. It's a little bit backwards, but like I said earlier, you can flip multiplication and it's the same thing. So basically I found my answer now. I think I now know that R is 9 and S is 5, and when we add them we do get 14, so we're all done. I do just want to like exhaust the rest of my thoughts though, because maybe there's a second solution, right? Like this R is greater than 0, like maybe I should have looked in the negatives. So I'm not there just yet. I just wanted to take a look at what's happening over here and here. Like the halfway point between 2 and 28 should be 15. So I will be adding and subtracting a 13 to get 2 and 28. And as I'm understanding this problem more, I'm realizing that this 15 times 13, this is way too big to get just 45. Whereas when we're looking on the other side of things, 1/2 or 0.5 times 7.5 is way too small for 45. So I already know that this one would produce a product between R and S that's too big because kind of this one fell into the same trap. So looks like if we kept looking this way, the product of R and S becomes too big, and if we look this way, the product between R and S gets too small. So we kind of have this like nice little Goldilocks zone where we kind of get both features satisfied. So R is 9, S is 5, the sum is 14. Let's go on a hunt for why this matters, I guess. And I think just for kicks, let's try a different strategy. I'll just graph it and I'll look for intersection points. So instead of using like R and S, I do want to just use X and Y instead, just so that Desmos actually shows us something on the graph. And so anytime you do x squared minus y squared, you're going to get a hyperbola. They have these kind of interesting slant asymptotes that create an x over the plane. And then we also had the product of the two numbers is equal to 45. This is also going to create another hyperbola, although this does look more like the reciprocal function, like 1 over x. Just, I guess, if we popped a 45 right there, we would line it up. Because, we could just divide both sides by x here, and then we would get some kind of like more function-looking notation out of this guy. But I'll just keep it as what it was on the calendar. And so here I can see that this intersection point is the one that we found while working through the problem on our own, 9, 5. This 9 represents R being 9 and S being 5. And if we look around, these kind of, the end behavior of all of these branches, they're all going in different directions. So really we're only going to find an intersection kind of close to the origin. And so the only other place to look is right here. And what do you know? There is another solution with -9 and -5. This makes a lot of sense to me because here, if you multiplied two negative numbers, you would still get a positive number. And here, when you square a negative number, this -9 times -9 is doing the same thing that +9 times +9 would. So we are still getting 81 minus 25, which is 56. And then here, it doesn't matter if we have a +9 and a +5, or if we just put two negative signs, we're still going to get 45 as that product there. So cool. I guess I should have known, honestly, to look here first at just the negative version of our answer, but I just figured, why not? Let's just show it on a graph just to have another way to confirm the other solution. So this sum is 14, and that matches today's date. And then that third condition was important just to rule out this kind of other solution that we didn't wanted. So I am all content. I think we're all done, and I'll see you tomorrow. Bye.